So this video is about how to factor polynomials by a technique called grouping. So I have an example on the board. 3n to the third minus 12n squared plus 2n minus 8. So we have a polynomial. And you might notice right away that it's different than the other polynomials we've been factoring because it has 4 terms. It's not a trinomial. And it also has a power of the exponent greater than 2. So things are a little different. So the tools that we've been using so far aren't going to work in this case. Special cases don't work, and all those other techniques we've been using with algebra tiles and although listing the factors is not going to work. So we have to dig into our tool belt and find a new tool, and that tool is called grouping. So what it does is we just chunk this into smaller groups. So I'm going to put parentheses around those 2 terms and make that a smaller group of the big group, so to speak. I'm going to do the same thing here. Now I can do that when something's all addition or all multiplication because of the associative property of addition and multiplication. It allows me to group things however I want, and the answer is going to be the same. So once I've got it grouped, what I want to look for is the greatest common factor. Now look at this first grouping. The greatest common factor will be 3n to the second. Now when I pull that out in that first grouping, I'm going to have an n minus 4 remaining. Now I'm going to look at the second grouping and do the same thing. The greatest common factor here is just a 2. So I'm going to put plus 2. And when I pull it out of there, I'm going to have n minus 4. Okay? So I've used the greatest common factor of both groups. Now what you'll notice right away is that when I've done that, hopefully it'll work out this way, is that I have a common factor of each of these groupings. I'm going to underline that to make it easy to see. So each of these has an n minus 4. So I know that's one of my factors. So then I can pull out the other part of it. So if I factor out an n minus 4 from this term, I'm left with a 3n squared. And if I pull an n minus 4 out of this term, I'm left with a 2. So my 2 factors of that rather large polynomial are n minus 4 and 3n squared plus 2. And it doesn't matter the order that I put the groupings in because multiplication is also commutative. I can switch the order and it's still the same. So I'm ready to do another example just to make sure you really understand it. So if I was to look at this one, 8x to the third plus 14x squared plus 20x plus 35. If I group the first 2 terms and the second 2 terms, I'm going to again look for greatest common factors of each grouping. In this case, it'll be a 2x squared, and I pull that out, I get 4x. These 2 multiplied together should equal that term. And then I'm going to have a 7, and 7 times 2x squared is 14x squared. Now in this one I can pull out a 5, it looks like. So I'd have 4x here, makes 20x, and then plus 7. And so once again, once I've got those greatest common factors pulled out, I look for a common factor of each of these 2 terms, underlining that just to keep it separate. One of the terms I know, or one of the factors, is going to be 4x plus 7. The other one will be 2x squared plus 5. And one thing I should mention, if you're not sure if these are the correct answers when you factored, you can work backwards by multiplying using FOIL, first, outer, inner, last. And when you FOIL this out and multiply these 2 factors, you should get this polynomial, the original polynomial, as now. One of the things I should mention is that you can sometimes change the order to make a problem easier or to make it workable or just to do it a different way. For example, in the problem we just did, I rewrote it up here without the parentheses. If I wanted to reorder it, and I can do that because it's all addition, I can change the order. If I wanted to write 8x to the third plus 20x, move this over here, plus 14x squared plus 35. Now, mathematically that should be the same because I just changed the order of an addition expression. Let's see if our technique will still work in a different order. So if I just group these first 2 terms and the second set of terms, I can pull out greatest common factors, but it's going to be a different greatest common factor. This time, this is going to be a 4x, which will leave me with a 2x squared plus 5, it looks like. And this, I can pull out a 7, and that'll leave me with a 2x squared plus 5 also. And so this time, I have a different common factor of each term here. Underlining those, one of them is going to be 2x squared plus 5, and the other one is going to be 4x plus 7. So we end up with the same two factors as we had before. So the last thing we need to look at in this video is what happens when the polynomial looks a little different. If you look at the example on the board, this one has an exponent for the x value of to the 4th power, which is bigger than what we've had before. And the coefficients are also kind of on the largest size. So before you start factoring, you always want to take a look at this and see if there's a single greatest common factor that you can pull out of the whole expression, the whole polynomial before you start. So you want to think to yourself, is there any factor that's common to 4x to the 4th, negative 8x to the 3rd, 12x to the 2nd, and negative 24x? And if you're thinking it has to do with a 4, you'd be right. So we're going to pull out a 4, but then I wonder if there's any x's we can pull out. And the greatest number of x's I can pull out would be 1x, because this term has 1x in it. So I can pull a 4x out of this whole polynomial, which would leave me, when I factor that out, with x to the 3rd, these two would multiply to that one, minus 2x squared plus 3x minus 6. Okay, and you could distribute the 4x to each of these terms to see if it does equal that. Now, once I have that factor, I know this is going to be one of the factors that multiply to make this whole polynomial. What I can do now is I can factor this part. So I use my same technique that I used before. I'm going to put parentheses here and here and make smaller groups. I'm going to look for a common factor of this grouping, which would be an x to the 2nd, leaving me with an x minus 2. And then here, the greatest common factor is 3, also leaving me with x minus 2. And I can't forget to bring down this factor here. So it looks a little funky with the parentheses, but let's not let that bother us. What we end up with here is one factor, that is 4x, times by a common factor to these smaller groupings, which is x minus 2. It's a little hard to read there. And the last term would be x squared plus 3. So when you have a larger polynomial with greater powers of the exponent, you might have 3 or even more factors that multiply to make that polynomial. Once again, you can always check by multiplying this out to work backwards towards your polynomial. Oh my God.